I'm here on the Hyperion booth with Anselm. Anselm, you're doing a lot of interesting things around digital twins. What are you guys up to?
Good question. Hyperion specializes in taking a large high voltage asset and digitizing it.
Okay.
It seems a very complex concept itself, but really what we're doing is taking something that's made out of metal and copper and turning those little things into intelligent, communicating components.
Okay.
How do I get a piece of metal that makes up a transformer to talk back to me and tell me what its help is?
So how do you do that?
So we do that with a technique using a special sensor that we've developed. It's a fiber optic sensor. It's called a distributed fiber sensing solution. And essentially, this is a piece of it that I've got in my hand here.
Right. It's a piece of fiber optic.
It's a piece of fiber optic cable. Very simple, very innocuous, and it's light, so it's completely impervious to electricity and so on. So it's the perfect medium for a high voltage asset.
So, I'm fascinated. Where do I put this on a high voltage asset?
Right, so we take a piece of metal at the core of a transformer.
Yeah.
We take a winding of a transformer.
Right.
We lay this right alongside the winding. And every meter along that winding, I can tell you what is happening on that winding. So if I'm loading this transformer, I know exactly what the state of the entire winding is. So on a large transformer, if the winding is 3 or 4 kilometers long, imagine I can tell you every meter what's going on. Now you have real control of this asset because I've digitized that cable, that winding, which we've never had before. A lot of people talk about digitizing. It's all about the data, the communication that's coming back. But I'm taking an inanimate dead object like a wire and turning it into a living, breathing, intelligent thing.
And to deploy this technology on a transmission line or whatever, do you build it into the cable? Do I wrap it around it?
Ideally, when you are laying the cable, you would place it right alongside it.
Wow.
Very simple. It's very lightweight. It's simple to install. And it's plug and play, really. We have a device at the end of the line, and you plug it in, and away you go.
So you mentioned, obviously, with the transmission lines, what other use cases would you see this being used in?
So right now, our first implementation was in a power transformer for a customer in Canada called Hyperion Connections. They were very happy. They understood the technology, understood the benefits to their organization by digitizing this asset.
Right.
It was a $500,000 asset.
Right.
They decided to give to Hyperion to digitize, and we've done that. Since then, we've got Electra, another customer who decided to do the underground cable in their substation.
Right.
You can understand why that's important, because once you've taken a cable and thrown it underground, it's out of sight, out of mind.
Yeah.
How do you know what's actually happening on that? So all the more reason to have fiber running along this. So we've done an entire substation. Over 3.5 kilometers of fiber was laid down to identify everything in that substation.
3.5 kilometers of fiber.
And covering all of the underground cables in that substation.
Wow, impressive.
We've done an air core shunt reactor to be able to tell you, digitize that.
Yeah.
Shown a little picture there.
Yeah.
And we've also, the Amarin in St. Louis, they're in fact taking us into their coal-fired power plants. And we are actually sensoring, digitizing the electrostatic precipitators. It's like a filter on the back end of a coal-fired generator. And today, after 40, 50 years of coal-fired generation, we still don't know how effective a filter we have.
Okay.
Because there isn't anything of that size to define what that looks like.
Okay.
And this can cover this entire precipitator. We would be using approximately 20 kilometers of fiber to sensor this entire precipitator. That's how large this structure is. But today we have a technology that we can even conceptually think that's possible. We can do that today.
It's a whole different way of looking at sensor.
That's right.
The fiber is the sensor. Wow.
The fiber is the sensor. Absolutely. So
that's pretty different. Hey, thank you very much. I wish you well.
Thank you very much. Pleasure having you.